Hi class. In this lecture, we're going to continue in chapter 7 by moving into section 7.2. And this is about graphing quadratic functions in what we call standard form. All right, so there's two methods we're going to talk about for graphing quadratic functions in standard form. The first is graphing using two symmetric points. All right, once you have the symmetric points, you find the vertex. So the part of the parabola that lies to the left of the axis of symmetry is the mere reflection of the part that lies to the right. Okay, so what we're saying here is for any point on one side of the axis of symmetry, there's a point on the other side that is what we call a mere reflection of the first point. Okay, such a pair of symmetric points, so symmetric points, what they have is they have the same, or their corresponding ordered pairs where their y values are equal. So their y values are the same, but their x values are different. Okay, make note of that. Y value is the same, x value is different. Okay, so to do this, what you do is you find the vertex of a parabola in which P, comma S and Q, comma S, notice how the y values are S are the same, are symmetric points. So once you've found symmetric points, what you do to find the vertex is you find the x coordinate by using the formula x is equal to the P plus Q divided by 2. So in other words, the x coordinate is the average of the two x coordinates of the two symmetric points. And then you find the y coordinate by evaluating the value you found in step 1. So you take that value you found in step 1, plug it into your function, and that is the y value of the vertex. Okay, so in short, the vertex is the following. The x value is p plus q divided by 2, and the y value is you took that value, p plus q divided by 2, plugged it into the function. Okay, so let's do an example of sketch this graph. All right, g of x is equal to x squared minus 4x plus 7. All right, so first off, the first thing you're always going to do, the easiest thing to do is find the y-intercept of the graph, okay? So to find the y-intercept, you set x equal to 0, plug it right in, and you see that the y-intercept is just 7. Okay, so this y-intercept is the point 0, comma 7. Now what we want to do is we want to find the point symmetric to this. Okay, so next find the symmetric point of the y-intercept. Since the symmetric points have the same height, okay, we know the y-coordinate is 7. So all we're going to do to find the x-coordinate of the symmetric point is substitute 7 in for the g of x. So you just have to solve this equation. All right, so notice how my equation was this. I'm just plugging 7 in for this, whatever the value of the y-intercept is. We'll subtract 7 from both sides. Factor. So you have something times something is equal to 0. So either the first factor, x is equal to 0, or x minus 4 is equal to 0. So the other value, the other symmetric point, notice one symmetric point was 0, comma 7. What we're saying is the other symmetric point is 4, comma 7. All right, so the points have a height of 7. All right, the points that have a height of 7 are 0, 7, and 4, 7. So these are what we call symmetric points, again, because they have the same y value. So to find the x-coordinate of the vertex, we take the average of the x values. So 0 plus 4 divided by 2 gets you 2. To find the y value of the vertex, take 2, plug it in, and you get g of 2 ends up being equal to, when you plug it into your function, it just ends up being equal to 3. Okay, so there's the vertex, 2, comma 3. All right, so if you were to sketch this, right, you would sketch the vertex at 2, comma 3, the y-intercept, and the symmetric point, and then you can draw the graph right through it. So to sketch the graph of this quadratic function, find the y-intercept, find the y-intercept symmetric point, find the average of the x-coordinates of the two symmetric points to find the x-coordinate of the vertex, find the y-coordinate of the vertex, and then depending on how accurate your sketch is, you might need to find additional points, but generally those three are just fine. So sketch a parabola that contains all the points that you found. All right, let's do a harder example here where the numbers aren't so nice. So let's sketch the graph of this one here. Negative 0.9x squared minus 5.8x minus 5.7. So again, find the y-intercept. All right, the easy thing here is the y-intercept is always just the constant at the end. So the y-intercept here is just 0, comma negative 5.7. That's the y-intercept. All right, so you need to find now the symmetric point to this. So set this equal to f of x and solve for x. You notice you get this. You factor, take out an x. So either negative x is equal to 0 or this is equal to 0. So when you solve this, okay, subtract this over, divide by 0.9, you get x is roughly equal to, you'll have to round it to negative 6.44. Okay, so that is the other x value of the symmetric point. So the points 0, comma, negative 5.7 and negative 6.44, comma, negative 5.7, they're approximate symmetric points. Okay, so to find the x-coordinate of the vertex, you average the two x values. So if you take the average of those two x values, you get negative 3.22. Find the y value then, just plug it into your function. When you plug this into your function, you end up getting roughly 3.64. So that means the vertex is negative 3.22 and comma 3.64. So plot the points and sketch the graph. Here's the vertex. Here are your two symmetric points, 0, negative 5.7, negative 6.44, negative 5.7. Now look, you can draw the nice curve through those points, just like that. Okay, so you can use a graphing calculator to verify the sketch, and you'll see that it works out just fine. All right, there's another way to do it. So you can, I actually find this one to be a little bit easier. So you can find a formula of the x-coordinate of the vertex, okay? As long as b is not equal to 0, the vertex is the y-intercept. So the x-coordinate of the vertex is 0. So if the middle part b is equal to 0, the vertex is the y-intercept, so that's great. But we can also use this. So to find the vertex of a graph of a quadratic formula, or quadratic function, find the x-coordinate of the vertex by using this vertex formula. The x value of the vertex will always be equal to negative b, whatever the b value is, divided by 2 times whatever the a value is. Always, always. Then to find the y-coordinate of the vertex, well, if you know the x-coordinate, just plug it into the function. That's it. So in short, the vertex is always going to be negative b over 2a, comma f of negative b over 2a. All right, so let's sketch the graph of this right here. All right. First thing I want to do is I want to find the x-coordinate of the vertex. So substitute 2 in for a and 10 in for b. So our formula here is negative b divided by 2a, or negative 10 divided by 2 times 2, which gives me negative 2.5. All right, so the x-coordinate, as I said, was negative 2.5. All right, so to find the y-coordinate, just plug this negative 2.5 into your function, and you get negative 5.55, or negative 5.5. All right, so there's the vertex, just like that, just using the formula. All right, so the next thing you want to do is find additional input-output pairs. So all you have to do is select integers close to the vertex and plot those points. So remember, the vertex was at negative 2.5. So I'll pick negative 3, negative 4, negative 2, negative 1. Those are close to negative 2.5. Get the corresponding f of x values by taking them and plugging them in. And you can see when I do that, I get the vertex. These are the values when I plugged in negative 2, negative 3, negative 1, negative 4. You can get a nice parabolic graph here. Okay, so for a quadratic function that looks like this, who has vertex hk, if the value of a is less than 0, like a negative number, the parabola opens downward and the max value is the y value of the vertex. If a is greater than 0, then the parabola opens upward and the minimum value of the function is the k value of the vertex. All right, let's start just talking about finding the maximum value here. So a fireworks shell is launched into the air. The shell's height, all right, in feet at t seconds is modeled by this function. F of t is equal to negative 16 t squared plus 200t plus 1. All right, when the shell explodes, so it goes off at the maximum height. All right, what is the maximum height here? Well, the graph of f is a parabola that opens downward. Okay, that's because a is less than 0, it's negative. Therefore, the vertex is a maximum point. Okay, so to find the t-coordinate of the vertex, let's find that the t value is equal to negative b over 2a. Well, that would be negative 200 divided by 2 times negative 16. Well, that ends up being 6.25. Well, to find the maximum height, what you have to then do is plug that into the function that you had, the model. So the maximum height occurs at 6.25 seconds after launch. Plugging that into your model, you end up getting that the maximum height of this firework is 626 feet. Okay, and you can see if you graphed it that you'll be able to verify this on your calculator. All right, so the vertex there means the shell will reach a maximum height, as I said, of 626 feet at 6.25 seconds and should explode then. Okay. Note the function f describes the shell height in terms of time, not in terms of horizontal distance. So the graph does not describe, just so we're clear, the path of the shell.